is the fractal method. So this is the method that is being introduced by TJ Fractor that is to overcome the some of the whatever the disadvantage was there in the constant factor and average factor methods. So this fractal method was been introduced. So in this method, the whatever the total trips for each zones are being distributed in the interzonal moment. So with the movement where there takes place between one zone to another zone. Okay, the movement which takes place from one interzone, from one zone to another zone, where there is an internal and there is a where the from each zone where there is an internal movement will takes place. No, so that for that approximation for the relative movement in the each zone. So this fractor trips to estimate this fractal trips of whatever the zone, okay, that would be distributed over the moments. So in this the total trips of the each zone are being distributed in the interzonal relatives are being first approximation, according to which there is an attractiveness in the each moment. So that is about the fractor. So where there is a mathematical relation between in this, that is Tij is equal to small tij into pi divided by capital Pi divided by small pi, capital Aj divided by Aj. So summation of t to I to k, so divided by summation of capital K divided by small k into Ti to k. I is the zone I to zone k. So what is this T is capital Tij? That is the future trips from zone I to zone j, where small Tij is the present trips from the zone I to zone j. Capital Pi is the future trips which has been produced at the zone I, and small pi is the present trips attracted to the zone I, and small pi is the present trips which is attracted to the zone j. Ai is the future trips which has been attracted to zone j. Aj is the present trips which have been attracted to the zone j. Small k is the total number of the zones. So consider, so whatever the trips are there, so consider there is a trip is like this. So A, B, C and D. Okay. So movement, so this is the diagonal. So where there is a movement, okay, where there is a consider movement from A to B and B to A. So B to A you can present here. So this is maybe 10, this is maybe 10. Okay, so it will be shown in the arrow mark. So this is what the trip from A to B, B to A. Next is B to C is like this, C to B is like this. Okay, so same way here also A to C like this and C to A is like this. This is what the trips from one zone to another zone. The distribution of from one zone and interconnection between the each zone, it will be shown like this. So C to D like this, D to C like this. So same way D to A like this, A to D like this. Okay, so this is how the trips will be distribution. So this is how the fractals method, where the mathematical relation from it is been induced from an interzone from one zone to another zone. The where in this fractal method is used. Next, there to estimate the traffic originating and the termination and terminating the act of each zone. So that is also required, but that is not there in the case of the fractal method. So where there is an originating and termination of each zone, terminating point or destination point, there where there is a required number of the growth factor and destination of the growth factor, that is not been established in that is not been established in this relation, so it is not there. So in which where I'm explaining about the future method, furnace method. In that furnace method, where that whatever the disadvantage are there in the case of the fractal method, that has been overcome by the furnace method. So next we'll go and see the what is the furnace method, how the analysis will be done in the case of the furnace method, and the what is the mathematical relation and their how the problems whatever how it can be solved, that we will see in the case of by the furnace method.